Okay, so now let's move on to another topic of vector. So this one is another method of adding vectors. It's called the polygon method. So the polygon method is also known as the head to tail method, wherein you connect the head of the first vector to the tail of the second vector. We have here an example of three vectors. So basically the polygon method is only used when there are three or more vectors. So we have vector A with 10 meters to the east, we have vector B 5 meters to the north, and vector C 5 meters to the west. So of course we will be needing the Cartesian plane again. Let's say this is your Cartesian plane, and this we only need the first quadrant for this one. Okay, so this, for example, this is your quadrant 1, right? This is your quadrant 1 and this is your quadrant 4. Okay, so let's try to graph the three vectors using the polygon method. So let's start with A. So vector A is 10 meters to the east. So basically you will just draw the vector on the x-axis. Okay, so we have here the vector A. It's vector A 10 meters. And then since it's head to tail, then you have to connect the head of vector A to the next vector, which is the vector B. So in vector B, that's 5 meters to the north. So it means its tail starts here, then going to the north. That's 5 meters. And then we have another vector which is 5 meters to the west. That's vector C. So the tail of vector C starts from the head of vector B, this vector B, and then going to the west. That's 5 meters. Now how can we add these three vectors? Then we will take the resultant force. So how to get the resultant force for this problem? So the resultant force will be starting from the origin and then connecting its head to the head of the last vector, which is vector C, right? So you connect the head of the resultant force to the head of the last vector, which is vector C. Then this is the resultant force. Now using your ruler, you have to measure this vector, and if you do that, you should get 7.1 meters, and the direction will be north of east. So what will be your angle for that? If you use your protractor, you should get 45 degrees. Therefore, the answer for adding all these three vectors will be 7.1 meters, 45 degrees north of east. So for our number 2 example, we now have the formula resultant vector is equal to A plus B plus C. Now, the formula can be derived as resultant vector is equal to A minus B plus C, or it can also be like resultant vector is equal to A plus B minus C, or it can be resultant vector is equal to negative A plus B plus C. So let's have the example number 2. We have three vectors here, and we have A 3 meters and the vector is represented by an arrow now. Then we have 2 meters for vector B, and for vector C we have 4 meters. Now let's try to use, let's say let's use this formula. Resultant vector is equal to A minus B plus C. So this is your Cartesian plane. This is your first quadrant, then it's your fourth quadrant. Now, using this formula, you have to consider the signs. So in physics, if it's negative, it doesn't mean that it's less than 0. It only means that the direction is opposite. Okay, so let's start with A. So we have vector A, that's 3 meters. That's positive A here in our formula. So that will be here. This will be your A. So that's 3 meters. Now we have here negative B, and then our B is 2 meters. Since it's negative, it means the direction here will be opposite. So instead of going up, the direction will be going down. Okay, so this will be your B. This is your A, this is your B, which is 2 meters. And then we have positive C. Then the direction of vector C will be as it is. So that will be 4 meters. Okay. Now we can connect the resultant vector. So from the origin, we are going to connect the head of the resultant vector to the head of the last vector, which is C, right? Which is 4 meters. So that will be this one. Okay, so you have the resultant force here. So this is your resultant force. Now, how will you measure the resultant force? Then you have to use your ruler in measuring the length of the vector, and use your protractor in measuring the angle. For our number 3 example, we have here 3 vectors again. So we have A 4 meters, vector B 3 meters, and vector C 6 meters. So as you can see, their directions are represented by arrows. So in graphing these vectors, we are going to use the formula resultant vector is equal to A plus B minus C. So since you have A, that will be positive, then B another positive, and C, which is negative, it means you have to draw or graph the direction of vector C oppositely. Okay, so let's start with A. So from the origin, that's 4 meters. So let's say it's 4 meters. Now we have here positive B. It means you're going to graph vector B as it is. So our vector B is like this. That's 3 meters. So we are going to connect the head to the tail of V. That's B 3 meters. Now for C, we have negative here, and this is our C. And since it's negative, we are going to graph it oppositely. So the 6 meters will be like this. The tail will start from the head of B, then graph. That will be 6 meters. From that, you can now get your resultant vector. So to get your resultant vector, you start from the origin and connect the head of your resultant vector to the head of the last vector. So that will be like this. So this one is your resultant vector. So using your protractor, you have to measure the angle here, and using your ruler, you have to measure the length of our vector.